Good evening, class. Today we're going to look at parallelograms. It's a very specific quadrilateral, and it's one that's going to be unique and we have to look at multiple times. The parallelogram, it's a shape, specifically a quadrilateral, with opposite sides that are parallel. So in this case, the top and the bottom are parallel, left and right are parallel. These parallel sides, we end up calling bases. Both of them end up being bases. Both sets, actually. So the one with one arrow mark, so the top and bottom here, is one set of bases. And the ones with two arrow marks here, the other ones that are parallel, are the other sets of bases. It can sometimes get a little bit confusing, but this is a parallelogram. Two sets of opposite sides being parallel. Now, the neat thing about this shape is if I would ever draw it, I notice two things about it. Is that this angle here look to be the same size. This angle and this angle also appear to be about the same size. This side and this side looks congruent, this side and this side looks congruent. And in fact, that's true. In our next theorem here, 8.3 and 8.4, if I know a shape is a parallelogram, a quadrilateral is a parallelogram, then its opposite sides are congruent. And if I know it's a parallelogram, I also know its opposite angles are congruent. In this diagram here, you see that the top and bottom are marked as congruent. The left and the right side are marked as congruent. And the angles across from them, or across from each other, are congruent. This is true for any parallelogram. Any parallelogram. So if I know it's a parallelogram, automatically true. So let's look at an example. Find the values of x, y, and z. So when I look at this shape here, I know it's not marked, and that's one failing of this, is I really should have marked it. But it is a parallelogram, okay? So even though it's not marked, you should know that this is a parallelogram here because I mentioned parallelogram. So I look, well, if it's a parallelogram, I know the opposite angles are congruent. So opposite angles, 55 degrees has to equal x degrees. Alright, what else do I know is true? Well, this here, did I use x twice? Nope, that's a y, my bad. 4y minus 35 degrees equals 125 degrees. Well, what else do I know? Well, that side and this side have to be congruent, so I also know 3z plus 5 has to equal 17. Now, I knew the angles across on a parallelograms are congruent, and the sides are crossed. So I could right away set up these three equations. And if I look at this, there's only x in this one, only y in this one, only z in this one. I've already done the hard part of set up. Now all I have to do is the math of subtraction, addition, balancing for x, y, and z. Well, this one, well, x is just 55. This one was a little bit easy. Get rid of the degrees. This one over here, these parentheses really aren't needed, so I'm going to pretend as if they're not there, and the degree symbol isn't needed because they're both in degrees. Furthest thing away is 35, so I add 35 to both sides, I get 4y to be 160. I gotta get y by itself, so divide both sides by 4, y is 40. Over here, 5 is the furthest thing away, so subtract 5 from both sides. 3z equals 12. Divide both sides by 3, z equals 4. So, the big thing from this, opposite sides and opposite angles of a parallelogram are congruent. So when I see a shape like this, I automatically know to set the stuff across from it congruent. The next theorem is, again, about if it's a parallelogram. Now, something you should note, that its consecutive angles are supplementary. Well, if this angle and this angle are congruent, and this angle here and this angle here is congruent. And even better yet, I look at a side like this over here. If I would redraw this side, but I'd add a few more extra lines. And I go back to chapter 3. Well, these are parallel lines, intersected by a transversal. And these are what we call consecutive interior angles. Wait, if these are consecutive interior angles, those are supplementary. Remember that whole thing, CIA, consecutive interior angles, then it's supplementary because the CI investigates supplements because they're sometimes used illegally. It's just an extension of that theorem. But we have a whole other theorem to just remind you to say, hey, if it's consecutive interior angles of a parallelogram, those two angles have to add up to be 180, supplementary. So in this case, 125 plus 55 is 180. In the case in that diagram over there, that's in the computer, PowerPoint, x plus y is 180. X plus y is 180. It has to be. Because if it's a parallelogram, those angles are supplementary. Theorem 8, we're going to an example right away. Find the measure of each angle. Exclude any straight angles, so any straight angles we're not going to pay attention to. So, in this left picture here, first of all, I know opposite angles are congruent. So 56 degrees, because that's 56. Now, the other two angles. Well, I know that this angle here, and this angle here, because they're in order, around the circle, around the polygon, x and 56 are angles that are consecutive. They're not adjacent, but they're consecutive. So that means x plus 56 here has to equal 180 because those two angles have to be supplementary. So x has to be 124. This has to be 124 degrees. Well, if this is 124, this over here is 124. Now let's just do a quick check to make sure that this all works out. What if I would add 56 plus 124 plus 56 plus 124? The question is, does that equal 360? Because all the angles of a quadrilateral should have to be 360. And it does end up being true. So, in this case, no rules have been broken. Let's take a quick look over here. Let's fill in the stuff that I know for sure. I look at this middle one here. Now, I could have tried to start up here or down here, but I'm going to start right here at the middle. Because I see a vertical angle. So I know 50 and 50 have to match up. And if this is 50 and this is 50, this straight line here means that this has to be 130. Because those two angles have to be supplementary. Well, if that's 130, this is 130. Alright. Next thing. If this is 75, this is 50, and I'm trying to find this angle down here, 75 plus 50 plus x, all has to be 180. 125 plus x is equal to 180. X is 55 degrees. Ooh, I could do the same thing down here. Well, let's call this one y. 130 plus 35 plus y has to be 180. 165 plus y has to be 180. Y has to be 15. Alright, so this was all stuff that we could have done before the chapter. This was vertical angles, linear pairs, the sum of the interior angles of a triangle add up to 180. But now I look and I'm kind of stuck. Because this triangle here has only one. This triangle here has only one. And even if I look at like a big triangle here, I'm still, actually I might be able to get away with that. Nope, I'm missing this part of this angle. I don't have both parts. Oh, I think I see something. This angle here is 70. And if I add it to this angle here, I should get 180. So when I add these two together, I should get 180. Wait, so let's call this here z. So if I add z plus 75 plus 55 plus 15, I should get 180 because the consecutive interior angles are supplementary. So let's add those together. Z plus 75 plus 55 plus 15 equals 180. z plus 145 equals 180. Z equals 35. So if I go in here, I see 35. Now, if I look real quickly, 35 and 35. Hold on a second. 35 and 35. Oh, parallel lines. Transversal, this angle and this angle are alternate interior. Consequently, alternate interior also is here. These are alternate interior angles. So I know this one's 75. Oh, let's just run with this now. Alternate interior angles. This angle and this angle here are alternate interior angles. 15 degrees. This angle here. This angle here, alternate interior angles. 55. And there I go. I found all the various angles. Yeah. You can use alternate interior angles like 75 and 75 here. 35 and 35. You should be able to use linear pairs, 130 and 50. Vertical angles, 50 and 50. Consecutive interior angles added to be 180. These are all tricks to find out all of the angles. I think I pretty much pulled out one from every single part here. But you need to know how to do this. I showed just one quick example. You'll see one in your homework. Do your best. Now, there's one last theorem we have to go over. And that's if a quadrilateral is a parallelogram. So if we have another parallelogram, we know that the angles across are congruent. We know that the sides across are congruent. We know that consecutive angles are supplementary. And this is all something that's a consequence of the sides being parallel. And the last thing that ends up happening is the diagonals bisect each other. So if I would draw a parallelogram, the diagonals have to bisect each other. What that means is this side and this side, this side and this side have to be the same. So if this is 3 and this is 4, this has to be 3, this has to be 4. Plain and simple. The diagonals bisect each other. It cuts them in half. Alright? So, if it's a parallelogram, the diagonals are bisected. They're cut in half by each other. Alright, let's just quickly do two examples here. Find the values of the variables. If I give you the diagonal's length. Now, in the book, I've had a few people in the past ask me, how do I know if this is a diagonal length or if this is an angle measure? Well, the book is very, very tedious about using symbols. And even I have been. I've labeled everything pretty much accurately almost all the time. If I put a degree in here, it's an angle measurement. If I do not put a degree, it's a length. Plain and simple. So, do you see any degrees up here besides the one that I had entered in? No. So these are all lengths. Better yet, these are diagonals. So I know that these bisect each other in both of these. So if I look over here, if those bisect each other, 3v and 6 have to be the same length. Z and 12 have to be the same length. Well, I've already found one of the variables, z equals 12. For v, all I have to do is divide by 3 to get 2. And that's because I knew the diagonals bisect each other. So I set the two parts equal. 3v equals 6. Z equals 12. You can go ahead and try the next one on your own real quick. If you were doing it correctly, you should have gotten this setup, 5x equals 20, and 12y minus 5 equals 15. Again, I know the diagonals bisect, so this part has to equal that part. This part and this part have to equal. Well, now that it's set up, the geometry part's done, it's algebra time. Divide both sides by 5, I get 4. Add 5 to both sides, 12y equals 20. Did I write that? I did not. That's not 12y. It's 2y. I made it look like a 20 by accident here with a tally mark. It's actually 2y. So 2y minus 5, add 5 to both sides, 2y equals 20, y equals 10. So if I look here, this section isn't horribly difficult. It's just knowing the new rules, which is opposite angles are congruent, opposite sides are congruent, consecutive angles are supplementary, and diagonals bisect each other. Yeah, there's a whole bunch of rules you have to remember from other chapters, but you should have been doing that anyway. We did a quick review on some of them. Hopefully you remember them. If not, look back at the chapter that I mentioned in each of them. And I believe that's all I have for you today. It is. So, till next time.